Hello, everyone. Welcome to the session of Semantic Arts. We have Mark Wallace from Semantic Arts here with us, who's going to speak about how to jumpstart your knowledge graph with the GIST ontology. Mark, the floor is yours.
Thank you very much, Ivan. I hope you can hear me fine. Hi, everyone. My name is Mark Wallace. I'm here with Semantic Arts. And yeah, we're going to talk about how to jumpstart your project with GIST. And without further ado, I'm just going to jump in on the slides because they say everything I want to say, and I don't want to miss anything. I hope you're all enjoying the conference so far. So first off, just a little, so who is Mark? If you haven't heard of me before, I'm an ontologist and a knowledge graph engineer, meaning the ontology is about 10% of what I find myself doing for clients these days. And the rest is things like actually mapping data into a large knowledge graph, helping them with querying the graph, getting it into production, and doing all the software kind of things that we do, with any piece of software, any data store that's being used in production. I've been with Semantic Arts since 2017, and I've been in the semantic web space since about 2004. So it's getting close to 20 years now. And so since then, I've been mostly building knowledge graphs and knowledge graph-based systems. I've been a speaker in the space since about 2009, and I have built many large-scale RDF and OWL knowledge graphs, both for the defense sector in the United States and as well as for some of the Fortune 100 companies here. So what I want to do is talk about GIST. Many of you maybe haven't heard of GIST. So what is it? GIST is what we call a minimalist OWL upper ontology. So the goal of GIST is to help get you going quickly. And we'll talk all about how it helps and kind of why you might need that. The idea is to get a good ontology quickly, and that's not always all that easy. And this is, applicable in the OWL, if you're using OWL ontologies as the basis of your knowledge graph. Some people may be doing property graphs and other things, just isn't really set up for that, but it is set up for OWL RDF stores and building OWL knowledge graphs. So now I really can't cover all of GIST in 20 minutes, which is what I'm going to try and do, 20 to 25 minutes, and let you ask questions. So my approach is to do what I call an overview and an interview. So the overview is kind of the general, explain GIST in general, and kind of try to explain why you might want to use it. But then to make it a little more real, I'll go into what I call an interview, which means I'm going to drill into just a few of the concepts, a few example use cases to give a feel for how you would actually use it. And I'm hoping that that will give you a sense of it, a gist of GIST, if you will, in what I can do in a 30-minute talk. So let's get started. Again, part of the overview, why use GIST? And to me, the first thing is because building good ontologies is hard. When I've been in, if I am in a live setting, I'll ask people raise their hand, tell me how many of you have tried to build an ontology from scratch and how did it go? And the funny thing is when I say, how did it go? I get a lot of laughter sometimes from the audience because they realize that, they've learned something about OWL and they try to get in there and build it, but it's hard to get a really good one going. A lot of times they end up not liking what they've done and throwing it away. We've seen a lot of bad ontologies over the years at Semantic Arts. We've been a consultancy in this space for about 22, 23 years now. And what do I mean bad ontologies? Some are just named classes with no real logical definitions. So if you know anything about OWL, you can define classes and properties. But one of the cool things is you can give strong logical definitions that help people understand what the class means. We're not big fans of just named classes with no other axiomization because it doesn't help you too much. The other thing we've seen is some ontologies are absolutely huge, in the tens of thousands of concepts. I think, there's one famous one out there that was over 100,000 concepts. And there may be great applications for that, but what we find is sometimes they're so big you can't possibly get your head around them. So it's kind of, you'll never really understand what you have at your disposal because there's so many concepts in there. Um, so that's one thing, and I'll get into more details on essentially how it's not got a high cognitive load or not a lot of concepts. Another reason to use GIST is you get to leverage tons of experience. So the GIST ontology has already gone through, it has thousands and thousands of hours of expert thinking. Dave McComb is at Semantic Arts. You may have heard of Michael Ushold, who um, has written books on OWL. They all are consultants there and have all put time in. In fact, they were the primary authors of some of the early editions of GIST. So you have a lot of expert thinking in there. It's not their first rodeo. GIST is not perfect, but it's constantly being improved. It's on version 11 right now. Actually, at the time I wrote this slide, that was true, and now just 12 is now out. But anyway, we have new versions coming out about once a year. So because it's not perfect, we continue to try to improve it more and more. But it has a lot of ontologist experience involved in it. And this is one of that plus this, I think, are some of the key reasons to use it. It's what I call small yet very broad. So what do I mean by that? Well, version 11 has 139 classes, 94 object properties, 39 data properties, and 3 annotation properties. I'm going to assume everyone here knows what OWL is. I'm not going to go into what those are. But that's only 275 total concepts. So this is the number of concepts that you could probably, if you spent a weekend looking at GIST, you'd be able to have your head around the whole thing. And that I think is very valuable, that the cognitive load is low for using GIST. It's small, but yet it's broad. So the idea as we have built it is the intent is to have a top level concept for almost anything you would model. So it's not, say, just a medical or business or financial ontology. It's really a starter set for anything you might need to model. And I'll get into some examples of that. Another reason to use GIST, I suppose, Semantic Arts uses it, right? I mentioned Dave McComb before and Michael Ushold. We use GIST as the starting point pretty much for all of the work that Semantic Arts does. We find it extremely useful because we have a well thought out starter set. We're not starting with a blank slate every time we come to a client. And again, like a lot of things, if you just keep reusing the same thing, you make new versions, you make it better and better. But after a while, you have a pretty solid starting point. Semantic Arts can't do all of the knowledge graph in the world, work in the world. So, darn it. So we kind of say, well, let's give back and put this freely available ontology out there, so that other people, can start with it, even if it's not a client that we're going to be working with. And as I just said, we put it out there for free. So GIST is open source. You can just download it and start using it. The only thing we ask is you don't change the namespace. So don't, take all the things and then put your namespace on it and make it seem like you made it up. Just leave it as Semantic Arts GIST and use it and extend it. Also, that's also to say this is not a product talk. I'm not trying to sell a product because we don't get anything for it. So it's not really a product sale. If there's any surveys, please don't ding me for being too much pushing my product, because I don't really have one in this case. It's just out there for free. And so, like, how will GIST help you jumpstart your work? So I've kind of alluded to it, but the main thing is it has out of the box concepts for, as I said, most of the things you should have to model. You should be able to at least root them into these classes. So we cover buildings, events, people, places, which can be geographic locations or landmarks or anything like that. Agreements, which is very interesting. They could have requirements are agreements, contracts are agreements. We have organizations. We have the notion of identifiers or IDs, which I'll give some examples on in a little bit. We have the reusable notion of a magnitude, a very generalized way of doing all magnitudes. So we have a variety of reusable date and time properties. We have a notion of ordered collections and just unordered collections. And we have a notion of categories, which I don't have a lot of time to get into, but sometimes things don't necessarily deserve to be a class. They just needed to be a set of category values by which you can categorize things. So we have primitives for all these things. And as I said earlier, one of the goals is just to allow you to have that starter set and kind of almost be able to find a place for everything. I'll go into a really short case study at the end that just kind of illustrates that a bit. So how will GIST help you jumpstart your work? This is now, I guess, the last little bit before I get into some specific interviews. But one of the things is it has logical definitions and what we call disjoints, meaning, the classes, you'll see the example here, this is one example, it's the GIST ID class. And it's just saying, okay, when we say there's such a thing as an ID, we don't just have a textual definition, we use axioms. So we say, okay, an ID is a kind of content, and the ontology will explain what GIST content is. And IDs are generally allocated by something. It could be intellectual property, like some algorithm, or it could be an organization or person who's assigning IDs. Like in the United States, we have the Social Security number, so there's an organization that puts those out. You can model all this on the IDs. And we're kind of explaining, hey, if someone wants to use our concept of an ID, what do they mean? And we're saying, well, it's content allocated by something, and it always has some unique text string. Even if that is numeric or something else, we treat it as a string. So that helps you get your thinking straight about what is an ID. And we also use things like disjoints, meaning if you look at just content, you'll see that it's if it's something you're thinking of using and you want to use this concept of an ID, well, what is it not? Well, organizations are not IDs or content. Geo points are not content. Units of measure are not content. So again, just by knowing what it is and kind of what it isn't really helps you get your thinking straight, helps you figure out which classes, really helps you define what classes really mean in relation to each other. Again, I'll give some examples of this, but and I think you'll kind of see what I mean by having rigorous definitions that aren't just textual or just a named class. It really helps you parse out your thinking a little bit better. I'll go into some examples very soon. Yes, I'm just looking at a few of the questions real quick, and I guess we'll probably jump on those later. But it's definitely an OWL ontology, and I'll go into some use cases right here to show you how you might use GIST, just to get your thinking started and to give you a feel for what it does for you. So let's do that. This is our interview of GIST, looking at some example applications. So let's take, for example, I'm going to have about 3 or 4 examples here. Consider you're going to model a report. You're doing this ontology modeling. Someone says, I want to model a report. Let's say it's a in the United States here, something called a 1040A tax return. Having GIST helps me think about, well, wait, what do I mean when I want to model a report? Because I'm trying to figure out GIST as a top level ontology that I can extend. Like if I mean a 1040A form in general, if I want to talk about the 1040A form in general is on revision so-and-so, or the US government produces the 1040A form, that's really something that GIST might call a template. Versus, do I want to talk about, like, is my model need things like Mark's particular 2022 1040A text form, like when I sent something in? Because the first one is, well, I could say the tax form is I'm going to subclass template. I'm talking about the thing in general. Whereas if I'm thinking about, I actually need to be able to model individual people's forms, right, and what they say, then we would say, okay, well, that's actually, now you're talking about something that's actual content, not just a template for content. And the specialization of a tax return might be, well, it's content, but it's also based on a tax form. And again, tax form is this thing we decided was a template. So it kind of makes sense. My particular form that I send is an instance of a tax return that is related to the general template, right? I fill in my numbers and everything, and I and it's good to know what's the general thing and what's the specific thing. So that's just one example. Let's say now you had to model metrics. Someone's saying we want to start modeling metrics, or essentially, captured measurements on things in our graph, whatever your domain might be. Let's say you're in an information domain and you want to model percent of data encrypted. People want to talk about, of my systems that I have, how much data is encrypted on them. And again, just kind of forces you to think about, well, what do you mean by that? Do you mean the general notion of the metric, which might be what GIST would call a template or a specification? You'll know we have root classes. We have a class called a template, a class called a specification. You'll see those in GIST if you poke around in there. Or are we talking about a particular measurement at a point in time? Right? When people say metrics, it's not always easy to know. And we found that by having GIST the way it is, and we have to slot classes into GIST, it makes us go, oh, which kind are we talking about? Sometimes language is somewhat, blurry, somewhat, people say metrics, and in some context, you know what they mean. Um, but in the model, you have to be explicit about what you mean. So the general notion might be a template, a particular measurement, like what is the percent of data encrypted on Mark's hard drive as of 8 o'clock this morning, right? Which would in GIST, it would instead be just has, as mentioned, events and a few subclasses of events. So in GIST, we would say, oh, well, now you're talking about a historical event, right? A metric that was measured at a particular time. The nice thing is GIST is based on predicate. So we might say a metric measurement is a historical event that's based on some template for the metric. And of course, being a particular measurement now, it's going to have some magnitude, right? So in this case, it might be what GIST would call an information quantity. So I mentioned we have a generic notion of magnitudes. Um, this one could even go more specifically, has magnitude of type information quantity. So how many bytes or bits are encrypted. Um, Let me go into just another use case. Right now, let's say you have to model insurance. So when you want to model insurance, you might have to model insurance policies. What's that? That's probably an agreement of some kind. And again, just has this top level notion of intentionality. And under intentions can be things like commitments, agreements, requirements ultimately are an intention. Um, so again, we could poke around and just and see that, but it seems to me an insurance policy is going to be some kind of an agreement, some subclass of agreement. Whereas if you want to talk about covered events in the insurance world, right? So what kind of events are covered? Again, just as a few subclasses of contingent event or of event, one is contingent event, right? And if we looked at just a contingent event would be an event with some probability of occurring, not one that has definitely occurred. So if you think about insurance, you might model events that can be covered at these are contingent events with some probability of happening. And I could say, okay, it's not only that, which is any contingent event is an event that has some probability. And I might say my specific insurance event is a contingent event and it affects some insurance policy, which you actually would have modeled as an agreement. And then what if someone has to submit a claim? Now something has actually happened. It's not just contingent. So now we might say, oh, well, claims, insurance claims, we might slot under historical events, meaning something actually happened. And so that's slightly different than a contingent event. And we even have this notion, again, under agreements, we have the notion of obligations. If you think about it, a claim might trigger what's called a contingent obligation, an obligation that the insurer would have to pay the insured if something happens, if a contingent event happens. So again, pretty complex things in insurance, and we're finding that with GIST, we only have to maybe go down one leaf level on each of these few areas, and it helps us think, what are all the things? What would a claim really be? What would a covered event really be? And you have some well thought out places to already slot them, like agreement, contingent event, historical event. Uh, Lastly, I think another example, we may have to model employees in our knowledge graph, right? So, okay, so it's almost certainly a person, right? Just has a person class. Not only that, but persons typically have multiple IDs, right? And so just has this notion of person. It also has a predicate is identified by some ID, generally some ID. So for example, you know, um, there might be multiple IDs by which a person is identified, like their employee ID, their tax ID, and just already comes with the notion of person identified by ID, the ability to subclass IDs, and we even have this notion of is categorized by. You might categorize the different IDs. So Mark's identified by an ID of category Social Security number and an ID of category employee ID, and I can our ID class presumes a value, like a string value, as well as categorization. So I could look up and find people by all sorts of different IDs. I would already have stuff in the graph for that. Your person might also have many categorizations, right? If you're modeling employees, you might say, okay, I need to have categories for salaried or hourly, direct or contractor. If you're in the government space in the United States, they have something called a GSA level. So like, anyway, any kind of things you might have to model employees by. We have the starter set for all that. So here's kind of an example. Maybe you say, okay, I'm going to create a worker class. I'm going to say that's a GIST person, and they're categorized by some, worker exemption type. So my workers are always going to at least be a person and have some, are they exempt? Are they salaried? Are they not salaried? And this is saying they're with anyone who's a worker is also something that's identified by at least one ID. So I know that's going pretty fast, but hopefully this is giving you an idea of some of the classes we have and how when you want to jump in and model something, there's a lot to get started with. If you get a chance to peruse GIST, which I hope you do, you'll look at the classes and look at the axiomization on each class. That's one of the joys or beauties I think of an ontology, an OWL ontology, is it's not just words. You can define all your terms in terms of other terms. And then the goal here is that when you then extend something, our recommendation is take a class that just already has been pretty rigorous about and explain how your class is different. Well, it's a person and it's categorized by a worker exemption type. Not all people in the world have a worker exemption type. My kid doesn't have it, but some people do. So that's what makes a worker specialization of just any person. Okay, and then I'm going to do just a real quick example, bit of a case study, but just on one slide of an example that we were able to do and kind of jumpstart something with just really quickly. So we had a client who owns a lot of big industrial complexes, and they wanted to do some modeling on what they call heat exchangers. It's kind of a little picture up there, these big piece of industrial equipment. This project, they just were putting their toe in the water. So they wanted to do, gave us 6 weeks and like 25K to model heat exchangers as kind of a pilot. And so we were able to actually get an ontology built by extending GIST and onboard some of their heat exchanger data and demonstrate it all within 6 weeks, 25K. In fact, we were on time and under budget. So if we had to start from a blank piece of paper, I'm not sure we would have been able to do that. And I want to just show you kind of how some of the classes, how this worked out in this very specific case. So a heat exchanger, pretty obviously is some kind of equipment. So GIST already has the notion of equipment. GIST has the notion of located in. So heat exchangers are equipment, and they certainly wanted to model their geolocation for service reasons, to go out and service one that's broken or whatever. They need to know where it is. They wanted to model engineering drawings that were about their heat exchangers. So we were able to say, okay, well, an engineering drawing is something GIST would call, I mentioned content before, and then we have the notion of content expression, when you take some intellectual content and actually put it in some format. So an engineering drawing would be content expressions about equipment, or actually about heat exchangers potentially. Engineering drawings would be more general, so about any equipment, and then we could model engineering drawings specifically about their heat exchangers if we wanted to. They wanted to model flow. GIST already has, I mentioned, a set of magnitudes and some subclasses of those, like ratio magnitudes. So flow is a certain amount of volume over time. Sensor measurements, right? They have sensors all over these pieces of equipment. They want to measure them. Well, sensor measurements are basically historical events that have some magnitude and are about some piece of equipment. Sensor notifications. They don't only want the measurements, they want something to sit there and send me a message, ping somebody and tell me that they were notified. Just as a notion of a message. And again, this would be sensor notifications really would be a message about equipment. Chances are they would also link back to the particular measurement value, which we talked about above. So they'd be able to get the magnitude and know which piece of equipment it's about when it happened. As you might imagine, they're interested in heat exchangers with temperature and pressure, and they wanted to model restrictions on those, right? They want to know when some sensor is saying this heat exchanger is going out of tolerance for some pressure or some temperature. Again, restriction is just, it just already has a model of restriction, which ultimately is below that top level intention, right? A restriction is really something you don't want to exceed. And of course, you would have restrictions would almost certainly have magnitudes, right? Temperature magnitudes, pressure magnitudes. Not to mention all of their pieces of equipment have IDs, right? They have different IDs, ways they identify pieces of equipment and their subparts. So we were able to model all that because we had such a rich set of concepts to start with, and just do a tiny bit of specialization, and off we went. So I know that was a whirlwind tour. I know we just have a little time for questions. To quickly recap, GIST is free. It's got low cognitive load, only 275 total concepts to learn. Then you can wield it like a pro. It's broad. It should have a covering concept for just about everything. It's not just for one particular domain. And the last thing I'll say real quick, you can influence it and make it even better. You can get involved. So you can just start using GIST. I have a URI there to go get a copy on the web. You can learn more about it by hitting our website or going to YouTube's Semantic Arts Inc. and watch some videos on GIST. And you can even go to GitHub and start contributing issues to GIST, and we work those. So, time for questions.
Thank you very much. We already have a few. You can read them.
Yeah.
Mr. Lane is asking, what drives major and minor version changes to the GIST ontology?
That's a great question. So some of you may or may not be familiar with something called semantic versioning. It's a semver.org. I just put it in the chat. So semantic versioning is a way to make your major and minor versions mean something, right? First position is kind of a major non-backward compatible change. I love that question because we, as kind of former software guy who's now doing ontologies, my thinking was, what's not backward compatible? And in our mind, not backward compatible means you've changed something about the meaning of your concepts that the reasoning will no longer be the same, right? So you don't want to give a new version of GIST that's going to change the way things get reasoned in an OWL reasoner. So for example, if we do something additive to GIST, we add a concept, that's usually a medium version. It's a new feature, but it's not really breaking it. And but a breaking change is if we change the definition of a concept or remove a concept, then we consider that a major version. So imagine we took out inverses recently, actually. We think they are adding to the cognitive load. So once we remove a property or a class, we definitely have not made it not backward compatible. So that would be a major version. Next
Question by
question.
Alex Carmen. Have you tried combining GIST with RDF data cube?
I have not personally. So I'm not going to spend a lot of time on the question because I have not done that. It sounds familiar. Some of our ontologists may have tried that. If you're welcome to reach out to me. I don't know if I put my email on here, but I'm mark.wallace@semanticarts.com.
We'll
Mark.wallace.
post it in the chat, and yeah, we'll connect
Fantastic.
you.
Okay.
Blagoy Jankuski is asking, for what purpose application was later used the model of heat exchangers that you developed?
For what application was it used? I guess that I left that to the client. They were doing kind of a quick pilot. So I don't know how far they took it. I think they were just dabbling their toes in the knowledge graph world. So I can't comment on where it went.
Alex, again, it's more of a comment, says that GIST looks useful as an upper ontology above building smart data dictionary, BSDD, which is a complicated suite of ontologies for building HVAC systems. How would you?
Good. I mean, I hope it is. That's the goal. I love that because originally we thought of GIST, like when it first started, we used to say it was a business ontology. But I feel like where we've taken it to now, I don't think there's any, again, heat exchangers aren't really businessy stuff, they're equipment. So I'd like to think, and we'd love to think that it's a good starter for almost anything. So I appreciate that
I
vote
have,
of confidence.
I have one question. How many customers have historically used the GIST ontology in all its versions?
That's a great question. I think Steve might be on the chat. I'm going to guess it's close to 100 by now. Like I said, we pretty much use it everywhere. I think very early on in semantic arts, they were, and this is before my time, Dave was probably rolling his own, so to speak. And again, just after a while, you begin to realize you have some good concepts that have some staying power. Why not just bring those along to the next one? and it's kind of moved from there. But at this point, we start everything with it, and the heat exchanger project was a perfect example. That was my most rapid development project, and I was amazed at how much we got done on such a very small budget.
Awesome. Thanks a lot for your time. Thanks to the audience for the questions and listening. Feel free to move to the closing panel of the Knowledge Graph Forum. Thank you for being with us. See you next year.
All right. Thanks, everyone.
Thank you.
Thanks, Ivan.